Welcome back, students, to this session of a new lesson in chemistry, that is periodic classification of elements. This is a very easy lesson and very interesting lesson. So let's get started. So in this session we will be dealing with two important topics. One is, why do you require classification? Why should elements be classified? That is topic number one. And in the next half of today's session, we will be discussing about the earlier days of classification. So how did they begin classifying the elements? Class 9, we have discussed about elements. We know that everything around us is matter, and matter is made up of pure substances as well as mixtures. In pure substances, we have elements and compounds. So, elements can be defined as species that contain only one form of atoms, or these are the simplest form of matter capable of individual existence, independent existence. Coming to the first topic of today, why is there a need to classify elements? Now, classification is mostly done on certain kind of observable features. For example, if we in biology we classify all organisms into 5 kingdoms: Monera, Protista, Fungi, Plantae and Animalia, based on certain similarities and certain dissimilarities. Similarly, when we talk about chemistry, as more and more elements got discovered, we know there are 118 elements present, of which 94 elements are naturally occurring. They are occurring in nature, and 24 are man-made elements or synthetic elements. So there are 118 elements. Now, if you have to study all these elements, it would be a big chaos. So, in order to make the study of all these elements easier, it is classified. Now, what are the objectives of classification of elements? As I already told you, it makes the study, understanding of the elements, comparing the elements and contrasting the elements very easy. For example, you want to compare and contrast the physical properties and chemical properties of two different elements. So when they are classified in a systematic order, it makes the studying and understanding much more easier. How elements of a particular group, they form compounds, how are the compounds formed by them different from the compounds formed by another set of elements. So this is very important. Not only that, it also helps us to analyze the properties of elements and compounds individually. So for example, if you say gold, what are the physical properties of gold? What are the chemical properties of gold? So we can study them. Now, there are 118 elements. It may not be possible to study all the properties of all the elements. When we group the elements into a certain order, if you study one element in that particular group, it is like studying all the elements of that group, because they would have had the same physical and chemical properties. That is why we classify elements. And also, another reason is we can predict the properties of elements. In case a element has been discovered, and based on their properties we can place them in a particular group, and by chance we can also predict a particular element, what properties it will have if it belongs to a particular group. So these are the objectives of classification of elements. Why is classification required? So it makes the studying, understanding and comparing and contrasting of elements and compounds of different types easy. It helps us to analyze the properties of elements in a orderly and systematic manner, and it also helps us to predict the properties of elements. So that is why we classify the elements. For example, uh, you want to purchase something from your online store, let us say Amazon.com. You are looking for a particular brand of, let us say, camera. Now, if the and you know Amazon has more than 2 to 3 crore of items. If all these items, right from stationery to grocery items to electronic items to your accessories, all were messed up, it would make the search very difficult, isn't it? But if you look at Amazon.com, there is separate section for groceries, separate section for electronics. So if you want to look for a camera, you just go and look at the camera section. Similarly, when you classify the elements, if you want to look for a particular element, you don't have to look at the entire table. You can just go and look at a particular group and then find it over there. So that is the beauty of classifying the elements. Now let us go to the next very interesting topic of today's session, that is, how did the history of classification look like? When was the first classification done and what were the challenges that they faced? So the first attempt at classifying elements was done by Lavoisier. You would have heard this name in class 9th, Lavoisier, in the laws of chemical combination. So Lavoisier, he classified all the known elements into metals and non-metals. This was the first attempt of trying to achieve order from chaos. That time hardly, I think, 18 to 20 elements were discovered. Now the problem with this classification is, the limitation is, what about elements who have properties resembling metals, at the same time they also have properties resembling non-metals, for example metalloids. So it does not speak about that. So this is the first attempt. The second attempt was made by a German scientist called Johann Wolfgang Dobereiner. Shortly, we call him as Dobereiner. He was a German scientist. He was interested in classifying the elements. There are a couple of points to keep in mind. During his time, that was around the year 1817, this was when he classified the elements. Approximately around 33 elements were discovered. 33 elements were known during Dobereiner's period, as well as chemical properties and atomic mass. And then he arranged the elements into groups of threes, into groups of 3 elements each in a vertical column. In a vertical column. Because in each group there were 3 elements, he called these groups as triads. Tri meaning 3. Calcium, strontium and barium. Lithium, sodium, potassium, chlorine, bromine, iodine. These are examples for 3 of the triads discovered by Dobereiner. So this is one triad, vertical column, one triad. This is another triad. So triad number 1, triad number 2, triad number 3 in the increasing order of atomic mass. For example, calcium atomic mass is 40.1, strontium is 87.6 and barium is 137.3. It is increasing. When he arranged them in this manner, he observed one interesting phenomenon, which is what he termed as the law of triads. He observed that when we arrange the elements in the increasing order of atomic masses, the atomic mass of the middle element will be roughly equal to the average atomic mass of the first and the third element, which is what is called as the law of triads. So, to put it in a simple formula, average atomic mass of the middle element is equal of element 1 plus atomic mass of third element divided by 2. So that is our law of triad. Let us look whether it is true or not. So we will take triad number 2. The middle element is sodium. So that is sodium atomic mass is 23. We have to find out whether this is true or not. So when we add the atomic mass of the first element, that is 7, and the third element 39 divided by 2, that is 46 by 2, which is equal to 23. There you go. So according to the law of triads proposed by Dobereiner, when we arrange the elements in increasing order of atomic mass, the atomic mass of the middle element will be equal to the average of the sum of the atomic masses of the first and the third element. In this case, when you add 40.1 plus 37.3, the average atomic mass will be 88.7 of the middle element. Similarly, in this case, when you add up, the average atomic mass will be 81.2. In this case, it is perfectly 23. So that was what Dobereiner observed. The limitation or drawback of this law of triad was there were around 33 elements discovered. Among the 33 elements, if you were to group them into threes, there should be at least 11 triads. But he could observe only 3 triads. The rest 24 elements could not be placed into such triads, which means that this is not a universal phenomenon or a universal law. That was the drawback of Dobereiner's law of triads. The next attempt of classifying came in the year 1866 by an English chemist called John Newland. He proposed this idea in 1865. The paper was published in 1866. John Newland. He was an English chemist. So, around this particular time, there were 56 elements that were discovered. So, some more elements were discovered. 56 elements were discovered. And Newland, he followed Dobereiner. He arranged the elements based on their atomic masses in the increasing order of atomic mass. and their physical properties. So atomic mass was used as a basis for classifying elements. So in the increasing order of atomic mass table, Newland calls his classification as the law of octaves. It is called as Newland's law of octaves, although it is not considered as a law. This is just one small portion of the 56 elements classified by John Newland. So as you can see, when he arranged the elements in their increasing order, so element number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and up to the 56th element, which was thorium. Okay, he observed that the 8th element will have properties similar to the first element. Like for example, when you arrange the musical notes in a octave, in the Indian musical system we have sa, re, ga, ma, pa, da, ni. 7th one, and 8th one is once again sa. So that is why he called his law as the law of octaves. So when elements are arranged in the increasing order of atomic mass, the properties of the 8th element will resemble the properties of the first element. Similarly, properties of the 9th element will be similar to properties of the second element. Now, there are certain limitations, drawbacks with this particular law of octaves. Drawback number 1. This law was applicable only to the lighter elements. Only to the lighter elements up to calcium. This similarity between one element and 8th element and so on was applicable only till calcium. After calcium, the similarity was not observed, which means it was applicable only to the lighter elements. Another interesting thing which you would observe in this table is, you would see that in order to fit the elements, two elements were grouped together. For example, cobalt and nickel are placed together. So just to make sure that they fit in the table. Now this has two problems. If you look at the table of Newland's law of octaves, cobalt and nickel are placed with, it is placed in the group where there is bromine and fluorine. The properties of fluorine and bromine are completely different from cobalt and nickel. On the other hand, iron, whose Fe, whose properties are very close to that of cobalt and nickel, is placed very far apart in the other extreme. Cobalt and nickel occupies the first column. Iron, Fe, occupies the last column. So dissimilar elements were placed together, similar elements were placed far apart, which is another drawback of Newland's law of octaves. Not only that, when noble gases were discovered, remember, only fit into the table, they could not fit into Newland's law of octaves. Another bold statement that John Newland made was that he assumed that only 56 elements are present in nature. Only 56 elements are present, and he went on to state that no new elements will be discovered in the future. Now that was a very bold statement to make, which is not true. This was in 1866. Now there are 118 elements law. Therefore, these are certain drawbacks with John Newland's law of octaves. So with that we will stop this session. Thank you.